So let's pick up where we left off. We had this transportation tab, well, it's a network diagram, and we were translating that into the transportation table. And so far we got through cell 1, and we saw that to go from cell 1 to 4, from 1 to 4, we had a cost of 5, and so we put our costs in. Then we had a cost of 4 for 1 to 5. Notice that I'm not putting this like this, right? Because that would normally be what we're doing. But since I'm not putting in the values of xij, I decided to just leave them for the costs. Okay, and so the other thing that we were doing that's new is that we're using big M here to indicate that going from cell 1 to 6 is really not possible. And so we're going to assign it to a very large cost. Okay. Okay, so let's continue then, going from cell 2. And from cell 2, we can go from 2 to 4 with a cost of 3, from 2 to 5 with a cost of 6. So we have a 3, 6, and then again, we can't go to the retail outlets directly from there. Okay. The next line is from factory 3, and so similarly we have costs of 2 and 8, and then we have 2 M's here, but in this case we're able to go directly from 2, or from factory 3 to retail outlet 8, I guess you could say it that way, or from cell 3 to cell 8 directly, and so that gave us a cost of 2. Good. And then let's see, that had a supply for number 3 of 300. Good. Now let's go to cell 4. That's the transshipment point. That's the new thing that we're working with. And so the question is, for that, what should the supply and demand be? Or actually, what should the cost be? So does it cost anything to ship from 4 to 4? And the answer is nothing. However, can we ship from 4 to 5? We cannot, and so therefore we'll put an M there. Now this is kind of an interesting thing here. This is actually where we're going to park our excess inventory. Remember, because when we constructed S, that was going to be a huge number, right? And so what's going to end up happening is this cell is going to take up that excess stuff that's in our system. Okay, and so then 4 can go to 6, 7, and 8, and we have costs of 10, 12, and 16. Okay, and then finally for 5, we also have M because 5 can't map to 4, and 0 for that cost, and then 7, 8, 9. Good. And then you'll notice that we still have a balanced transportation problem. We have 700 plus 2s. 700 plus 2s is the total, and where s is equal to 700. Okay, good. And so now we can solve that transportation problem, and it's kind of fun to do it by using the spreadsheet. So let me pause for a second while I pull up the spreadsheet and we can take a look at it. Okay, we're back, and I've got the Excel spreadsheet loaded into actual Excel in this case, and the top of the thing is a lot different here. Just to give you an idea, to get the solver, you have to go to File, and then you have to go all the way down to the bottom of this green side here, back down. Oop, I don't know if I can show it on the, there it is. Oop, darn it. You have to go to Options, which is the last option down here at the bottom, and if you see that, then you go to Add-ins. I know you can't see everything I'm doing there, but you may be able to find it. And then there's a solver add-in that would be here if I hadn't just added it in. Okay, so how do you know that if you've got it added in or not? Back out here in the Excel spreadsheet, over here you can see that we have the solver. Okay, and so Now that we have the solver, we can see our solution. And so the idea was that we're just putting in these cells. You remember that we're reserving these for the costs, right? And then these are the cells that are going to actually contain our values. Actually, that's these values. Okay, so these are being used for the inequalities, and these are being used for the inequalities. So this is like the current value of the left-hand side of our LP. These are the right. So you see that they're equal, right? Here you can see up here is our costs, and so I just if you look up here, I just set the value of m to be 5,000, which is plenty large for this problem. Okay, and then down here you can see what the solution is. And so what's interesting is that we have 400 and 500 units being just stored in warehouse 4. That is, warehouse 4 is shipping it to itself because it costs 0 to do that. And so we also have 500 going from warehouse 5 to warehouse 5, and so that's also just kind of sitting there. Okay, and so then we have factory 1 sending all of its supply to warehouse 5, and then warehouse 5 is sending everything that it has to retail outlet 7. It's going to need some extra input, right, for warehouse 5, and so warehouse 5 is also getting 100 units from factory 2, and it's shipping its 200 units from factories 1 and 2 to retail outlet 7. Okay, it's shipping all of its stuff to retail outlet 7. And notice here, factory 3 is shipping everything it can to directly to retail outlet 8. And you remember that this cost was really low, and so it's liking that cost. Okay, and so you can see the other solutions that we have going here. So you might take a look at this. Remember how this works. I'm not sure if I can do this live or not. Let's see, I've got my drawing instead of my data. Let's go to, where is my editing here? Where's data? There it is. Over here, I see solver. So if I hit on the solver, oh good. And so this looks just like the other one. You would hit minimization, and then remember our objective function is cell D something. I can't see it. But you could fill in these just like we did before. Okay, and then for the solving method, we actually don't have a nonlinear system. We have a simplex. Hey, look at that. All right. And so, yeah, I'll just go ahead and leave this, let you play around with it if you have Excel. Otherwise, if you have LibreOffice, the solver is built in, and it's fairly easy to look at as well. Okay, so I'll close this down. Some of the cells will come with formulas attached, so you can use this. Excel sheet as a starting point. One of the homework problems is to actually solve one of these transportation simplexes with a transshipment point in between. All right, so I'm going to stop the problem here. I think you'll be able to read through the rest of the notes. There's one more example. I would really encourage you to go through the last example on the notes, see if you can write down the diagram of the network, and then from that put together the transportation tableau. And I also have a different way of writing down the linear program that may be kind of nice. In fact, I think I will just mention that. So if I take a look at this transportation diagram here, then the way the linear program works is that you just go through for each cell, and you look and you just set the input equal to the output. So for example, if we take a look at cell 3, then the lines would be, I have 300 coming into cell 3, so I would say that 300 equals, and then the output is going from 3 to 4, that's x34, plus the 3 to 5, so x35, plus x38. Okay, and so you just go through and you write down the equation for every cell, and that gives you your linear program. So you have eight lines, and those are written in the notes. Good. So I think this is kind of a fun section. It's a nice extension of the transportation problem, and I'll let you experience for yourself. Okay, I'll talk to you later.